So network evolution then, obviously back in the 90s when we built the GSM network, there was a category or a part of the network which we could generally refer to as the RAN. But the RAN included both the base station component itself and the controller, not too dissimilar actually from the 3G network. So 3G similarly had a radio access network in which there was a controller and there was a separate base station node. Now, in both the case of the GSM BTS and the UMTS node B, it's not too unfair, I think, to refer to these like dumb nodes. They weren't really doing a great deal of thinking. I mean, there was a lot of processing going on in those things, but not much thinking. The base station controller and the RNC, of course, they do things like radio resource control, or if you prefer, radio resource management, is a thing that both the BSC and the RNC do. And that includes things like handover, power control, mobility, quite a bit of signaling as well needs to be exchanged. In each of these cases, like the RNC, for example, might be connected up to in excess of, say, 200 node Bs connected back to an RNC. May not be as much as that, maybe more than that in some cases. Now, that meant that the RNC has got a lot of thinking to do because it's connected to a lot of base stations, and those base stations are supporting multiples of users, maybe dozens of users. So that means that the RNC then is a focus point for processing load. Thinking about power control in CDMA systems is kind of difficult, mobility and everything that comes on top of that. So when it came to 4G, we decided to change the architecture of the radio access network. But in this time, because we are looking here from sort of kind of release 98, if we can use that. It's actually GSM phase 2 plus and such like. But by the time we get to here, we're looking at a release 99 network. And there was actually nothing wrong with the core. The core is okay. But in release 4, we start making modifications to the core. So we've added some, we've always had the circuit switching stuff. And then a bit later on in 96, 97, we added the packet switch core for GPRS, of course. And then later when release 4 rolled around, we started making modifications to the circuit switching core and so on and so on. But eventually by the time we get to release 8, we don't need any of that anymore because we've got an LTE network. And it certainly looks like the access controller has sort of disappeared. Now, that, of course, is not the case because you still need those functions in the network. You still need radio resource management in the access network. So, of course, what we did is we basically put it in the base station. So the base station now does its own radio resource management. That makes perfect sense because now the radio resource management part of the base station only has to worry about the mobile devices that are directly in its own sector. And we have to worry less about those which are in other base stations. I mean, that's a bit of a problem for the RNC because the RNC has to worry about many, many mobiles. And the reason we've got this picture and the reason we basically say that what we did is we got rid of the access controller, we stuck it in the base station is because when we look at the 5G network, we suddenly decide, well, it's quite a good idea having a separately specified radio network control function and a separate base station-like function. It's nice to have those things separated because it gives us a great deal more flexibility in terms of designing and building that part of the network. And the other thing we did as far as LTE is concerned in the core network is we got rid of the telephone switches. Anything that looks like a circuit switch or an SS7, we don't need those things in the network anymore because LTE's job is just to move IP packets. And indeed, that's what it does. And we have a control plane, we have a user plane. The user plane will flow IP packets through tunnels and connectors to external packet data networks, which could be the IMS for things like voice over LTE, or it could, of course, be the internet. So, yeah, the modification of the network was fairly extensive when we jumped from 3G to 4G. Now, it is quite a big jump. Certainly in terms of the specification, it's almost like we could have drawn a line right through the middle here and said, right, brand new network with minor interworking sort of between the two, maybe a little bit of interworking. We only did that like 10 years ago. Yeah, we don't necessarily want to have to draw a line under the LTE one and say, right, okay, you go and buy a bunch of new stuff and build a brand new network that looks completely nothing like the network that you already had. Because this is quite a big hurdle here to get over that boundary. I mean, obviously the vendors, they allow us then to evolve the network functionality bit by bit, or maybe by software. We can update the base station via software to make it into a 4G base station and so on. But architecturally for 5G, we need more grace. We need to be able to evolve in a much more sophisticated way. Because 4G is not going away. It is after all the long-term evolution. It's going to be here with us probably for, well, at least another 10 years, possibly 20, maybe even 30 years. LTE will be with us. So whatever it is that we think is a 5G, has to coexist with the 4G for the foreseeable future. So we got to provide all kinds of interworking options or opportunities between the 4G and the 5G. And that's something we'll explore at length a little bit later on. I mean, this is the simplest and probably the most stupid picture we could draw of the 5G network, but here it is, nevertheless. I mean, it's a radio network after all, or at least this part of the 5G that we're talking about is a radio network. And it includes, well, unsurprisingly, a radio access part of the network. There is the core network part, and then you have your external PDN, packet data network. Now, the stuff that sits at the outside here, that's the sort of service and maybe the application domain sits out here. So if you want your network to do sort of fancy things, then you've got to put stuff in here. The difference now between, say, 4G and 5G is that the core network in 4G, of course, would just move packets through, with a bit of quality service on the side. But now, where you've got different services and applications with different requirements, if they are sufficiently different enough, then the option within 5G then is to provide different core networks by means of slicing for different services. So the core network is quite different. It is a data center. It is quite literally a cloud in which you host virtual network functions. But yeah, the interesting stuff really is what happens in the access network. One thing I'll say about the 5G core, the 5G CN, you may often receive being referred to as, is given that it's a data center, okay, which is just running a bunch of software pretending to be a network, what you could do is you could configure part of that data center to support the 4G network. So you may put in here, in fact, it's probably essential, that you put the EPC inside of your 5G core network, albeit a virtualized version of that. So a VEPC. Now, you may already have some or part or all of your network may be considered to be a virtualized EPC. But to support the evolution through the various options that we're going to get to, at least one of those options requires that we're able to host a virtual version of the EPC in the 5G core network, such that we are able to support then in the access network, multiple and various and interesting forms of interworking or interoperability. Because one thing you'll notice about this network, this effectively is the NG RAN, depending on how we look at it, but the next generation radio access network, so 5G radio access network. And of course, what you'd expect to find in there would be 5G base stations. The base stations, by the way, are now being referred to as the G node B, as opposed to the E node B. But one of the things about the 5G radio access network is that it basically has to support the inclusion of 4G base stations. Many of the early evolutions of the network will be predominantly in support of 4G base stations, where the 5G base station is secondary to the LTE master, but in support of things like carrier aggregation, dual connectivity, and various options 3s and 4s and 7s and so on that we have in there. So the NG RAN is able to host either a proper full-on 5G base station or 4G base station with various levels of master and secondary and so on. But we're going to get into all of that stuff.